This video is going to explain how to add radicals, radical addition. And I'm going to use page 10 in your notes. And I've got some other problems copied on additional paper. So go ahead and get a sheet of your own paper out to take the notes on. But this is the basic property. I think the easiest way to explain this, to tie it back to a previous skill, you can think of adding radicals like combining like terms, adding like terms. But the thing that would make the terms like terms is the fact that the radicands must be the same, and the radicand is the number underneath the radical. So when the expressions have been completely simplified, if the numbers under the radical or the expression under the radical, the radicands, if they are the same, then you can add these together. You can combine these together. So the basic rule example that I have here, the square root of 2 plus the square root of 2 would simplify down to 2 times the square root of 2. So I want to switch for a minute to some notes that I've made to try to link this back to an older skill and give you some simple. I would like to compare adding to multiplying, and then I'm going to move back to this sheet and I'm going to do the problems on this sheet. So to go back to a really basic old skill, if I simply had x plus x, I would simplify this down to 2x. To take this up to the next level, if I have the square root of x plus the square root of x, I have to do a few things. I have to check a few things. First of all, I need to make sure that the index is the same. So they both have an index of 2. And then I need to check the radicands, the number or the expression underneath the radical. I must have matching terms underneath the radical. So here I have the square root of x plus the square root of x. I would simplify this as 2 times the square root of x. That would be my simplified expression. Not to be confused with the square root of x times the square root of x. So the operation between the expressions makes all the difference. So here, if I'm multiplying these, this is now an old skill for us, I would have x times x, or x squared, and this would simplify down to just x. So when I'm adding versus when I'm multiplying, two different ways to think about it. Looking at the next example that I've created, the mental check I need to do, they have the same index, they're both square roots. Then I go underneath the radical. I have the same expression underneath each radical. The radicands are the like radicands, radical 3. And then to combine this as one term, I would think of this as 1 radical 3 plus 2 radical 3. So I would bring the numbers outside the radical together and add those together, and that would simplify down as 3 radical 3. And as I'm doing this, I realize that's maybe not the best example with all of the 3's. So I'm going to change this problem, and I am going to say that, let's pretend like this is 4 radical 3 plus 2 radical 3. And so now, changing it, my new problem, I would add the 4 and the 2 together to get a 6, and then the radical 3 would be that's the like term that I'm combining together. I'm combining radical 3's together, and the number of radical 3's that I have would be 6. 4 plus 2 giving me the 6 on the outside, 6 radical 3. The original problem that I had could have been a little bit confusing because of all the 3's there, so that's why I changed it. And if I were multiplying these together, and let me go ahead and alter my multiplication problem so that it looks exactly like the altered problem that I just wrote. So here, if I were multiplying these together, I would multiply 4 times 2 to give me 8. And then I would have 3 times 3, or 9, underneath the radical. And this would actually end up being 8 times 3, or 24. So you can see, comparing adding and multiplication, two different ways to think about it, two different answers coming out of both, depending upon the operation that's between the two expressions. And then the last example that I've made up, I've got radical 5x plus 3 radical 5x. And here, same index. And then underneath the radical, the expressions are the same, so they would be considered like radicands, which means I can add these together. And here I would think of this as having a 1 in front of it. 1 plus 3 is 4. And then I would have radical 5x. And that would be my simplified expression when I'm adding these two together. To compare this to multiplication, an old skill, here I would have 3 And then underneath the radical, I would have 25x squared. And that simplified expression would be 3 times 5x, or 15x. So you can see that the operation between the two expressions, you handle that in a different way. I'm now going to move back to the notes. I'm now going to move back to page number 10. And at the top, I have this example, the square root of y, the square root of x plus the square root of y. It does not equal the square root of x plus y underneath the same radical. In fact, this would be considered already in its most simplified form because they're not like radicands. So this is already as simplified as it can possibly get. In this state right here, that would be the most simplified form. All right, let's break these down. So the examples that I had, the examples that I wrote on my own sheet of paper, they all of the expressions already had like radicands. So here I want to do some problems where you don't have like radicands. So the first thing you need to do is simplify each expression before you consider whether or not you can add them together. So radical 45 is 9 times 5. And let me color code, I'll switch ink colors. And then radical 80 is 16 times 5. So I need to simplify each expression before I can determine whether or not they can be added together. So the square root of 9 is the perfect square. The square root of 9 is 3, leaving this expression as 3 radical 5. And I'm going to add that to 4 radical 5. So I simplify each original, and now I see that I have matching radicands, so they're now considered like terms for radicals, and I would simply add the 3 and the 4 together to get 7. And my simplified sum would be 7 radical 5. Let's look at the next problem where I have 3 terms together. So here I'll color code this as well. I'll do radical 72 first, so that's going to be 36 times 2, and I'm going to add that to radical 98, which is 49 times 2, so that's in pink, this one's in purple, and I'll do this last one in orange. So here I'm going to have 100 times 2, so simplifying, or breaking all of these down. I can't consider adding them together now, and until I simplify each of the 3 expressions. And so now I'm going to have 6 radical 2 and 7 radical 2 and then 10 radical 2. And then I do my mental check. I see that the radicands are all the same, so I now just simply add the numbers outside. 6 plus 7 plus 10, giving me 23 radical 2. So my simplified sum would be 23 radical 2. And doing the last problem together, adding in some variables here, and I'll do the same thing. I'll color code this as well. So my first expression is going to be 4, let's see, x cubed is not the perfect square, x squared is the perfect piece, leaving me with 3 times x, so that's the first, color coded in purple. And then I'll add that, I'll go with orange. And then 243 is going to be 81 x squared, and then the non-perfect portion being the 3x. So simplify, cleaning this up. It leaves me with 2x radical 3x and 9x radical 3x. So here, before I can decide whether or not I can combine these, not only do I have to have like radicands, but the numbers sitting outside the radical must match as well, or the expressions outside the radical must match as well. Here I've got 2x and 9x, which would be like terms, an old skill. 2x plus 9x is 11x, and then radical 3x, that portion coming together. And I will stop the video here, just a basic introduction to adding. I will stop the video here, and I have a subsequent video where I go through a different problem set, and that should be sufficient practice.